This one is increasing here. And what about this piece? That stays constant. So you can have a function increasing, decreasing, staying constant, but that's what decreasing means. As x increases, the y value is dropping. Think of it as a plane landing. As you're approaching the airport, what's happened to the y value? You're dropping, decreasing. Taking off, that's increasing. As you're traveling, you're going higher and higher. That's an increasing. When we travel, we go left to right in the positive x direction. When you're in the middle of the flight, the plane stays level. Like if you go into Florida, the plane will take off to a certain height. That's increasing. Fly straight for a while. Then when you get approach the airport in Florida, they start to decrease. So you have increasing at the beginning, then you get constant, then decrease. Now, why is it in this chapter? Because the first derivative actually can tell you where the function is increasing, decreasing, and possibly what we're going to call min-max point. Notice if I have a problem that looks like this, I'll make a normal one here. Let's say the graph looks like this. Now I'll say I'll pick, these are the point value, the peak values. So up to here, it's increasing right here. Anywhere else also increasing? Right here. What about this value? That's decreasing. Now he's going to other class to distract. This is actually, when you look at this picture here, that's your what? This point. Is that a min or a max? Exactly, that's a min point, relative min or local min. Well, you can spot a relative min. How? If the function is decreasing, then increasing, that point has to be a min point. This point here is actually a max point. You can spot the max point if your function is increasing, and after the points start to decrease, as long as there's no hole in it, then that's a max point. So we're going to use the first derivative test to tell us where the function is increasing, where the function is decreasing, and where the min and the max going to be. How do we do that? We look at the derivative. If the derivative is greater than 0, the derivative is larger than 0, that tells you your function is increasing. If the derivative is less than 0, the function is what? Decreasing. And if the derivative is 0 equals to 0, I'm going to say possible. It's not always guaranteed, but possible. If you are going to have a min or a max, they'll be there. But I don't want you to think just because the derivative is 0, there has to be a min or a max. The answer is no. But if you are going to have a min or a max, it will be where the derivative is 0. Or, in a few minutes, when you have a v, because notice if I have a v there, there's no derivative there, could be where the derivative is undefined, when you have a v shape. But for the example I'm going to use for now, it's going to be nice and smooth ones. I'm not going to use any v shapes for a few minutes. So let's take an example and see if I can tell you where the function is increasing, where the function is decreasing, and my possible min-max. Given f of x equals x to the third minus 1/2 x squared. Now, I want you to tell me where f of x is increasing. That's question number one. Question number two is f of x decreasing. And question number three, if you are going to have a min or a max, your possible min-max, where are they going to be? If you're going to have them. Three questions. Now, to find the answers to all these, here we go. Let's take the derivative. The derivative of that will be what? 3x squared minus what? 1x? What I'm going to do is take the derivative, set it equal to 0 to find the critical values. Set the derivative equal to 0 to find the critical values. So here we go. 3x squared minus x, set it equal to 0. Factor an x out. 3x minus 1 is equal to 0. X has to be 0, or 3x minus 1 has to be 0, which means what? 3x equals to 1. X equals what? 1/3. So I need to find out where the function is increasing, where the function is decreasing. I'm going to make a table. That table is going to grow, actually becomes much larger next class, or not next class, even today. But next class definitely will be much larger. I'm just going to set up for the future there. So normally today we're going to be looking at the first and the second derivative. So now let's look at the first derivative. This is negative infinity here. This is infinity. So here we go, the first derivative, and that should tell me everything I need to know. I'm going to take this and break it down to 3 parts. Why 3 parts? Because I found 2 critical values. One at 0, one at 1/3. So this is the 0, and this is the 1/3. And just to practice for the future, I'm going to find the y value when x is 0. When x is 0, what is the y value when you plug it in? Isn't that 0? And when x is 1/3, what's the y value? That's 127 minus, what is 1/2 times 1/9? Is that 118? Was that 54 the LCD? Can you divide 54 by both numbers? 54 divided by 27 is 2. 54 divided by 18, is that 3? Yes. Yep. So I can make it 54 here. This will be 2 over 54 minus 3, negative 1 over 54. So the y value is negative 1 over 54. And what I'm going to do, to find out where the function is increasing or decreasing, I need to know if the derivative is bigger than 0 here or less than 0 in every one of these. Well, how would I know in this segment? This is from negative infinity, that's where we're going to 0. That's that interval, from negative infinity to 0. How would I know if the function is increasing or decreasing? And this one, x between 0 and 1/3. And this is x between 1/3 and infinity. Oh, infinity, not 8. I have to think now. So how would I know if the function here is increasing or decreasing? We take a test point. Any point in that interval. Pick any number that you want, and you plug it into the derivative. So what do you want to use between negative infinity and 0? And be reasonable there. Negative 1. Okay. Any number between 0 and 1/3. Bigger than 0, less than 1/3. I could use 1/4, right? Between 1/3 and infinity, how about a 2? I could use a 1, 2. And now plug it into the derivative, not the function, the derivative. What is the derivative at negative 1? If the value is bigger than 0, it's increasing. If the value is less than 0, it's decreasing. It can't be 0 because 0 is for these values, these lines. When it's negative 1, this will be 3 times negative 1 squared minus a negative 1. 3 plus 1, which is what? 4, positive or negative? All I need to know is that value positive or negative. It's positive, which tells me the function is what? Increasing. Let's take the derivative at 1/4. 3 times. What is 1/4 squared? 1/16 minus 1/4. This is 3/16 minus 1/4. That's 4/16. The result is negative 1/16. It's a negative value. That tells me the function is what? Decreasing. And what about after the 1/3? How about the 2? When x is 2, what do we have? 4 times 3, which is 12. Minus the 2, that's a 10. Is that positive or negative? Positive, that's increasing. Increasing, decreasing, increasing.
Could you just find the first one? And since that
It's not always. Nope. He's like, oh, since you found the first one, the pattern. Nope. You'll see in a few minutes. I'll give you increasing, increasing, decreasing, increasing. You know, especially when you have critical values. So where's the function increasing? I'll give you 2 answers. X is less than 0, or x is greater than 1/3. Where is the function decreasing? X between 0 and 1/3. Do we have a max or a min? Notice the function is increasing, then decreases. What is that point? That's a max. This one is decreasing, then increasing. That's what? Min. I could even graph it right now. Actually, that's section 5. I'm not doing it today. How to graph using the derivative. I have an idea what the graph looks like. I can't graph it yet. And I'll explain why I can't graph it. All I know right now is I have 2 points. 0, 0. That's 1 point here. And I have a point where? I have a point 1/3 and negative somewhere here. Below that. This one tells me your function up to 0 was increasing, but it doesn't tell me how it's increasing. So it could be like this. I'll give you other options. It could be like this. Could be like this. That's all increasing. Could be like this. That's all increasing. I can do any one of these. Then it decreases between this and this, then increases after that. That's really the idea of what the graph looks like. Well, how do we know how is it increasing? Is it increasing like this? Is it increasing like this? Is it increasing like this? There's no way of knowing till we cover the second derivative. The second derivative is going to tell us how the function is increasing, but not the first derivative. So we got to wait for now till we get to the second derivative. Then we'll tell you everything about how is it increasing. And if you get a point like this point, that's called a change of concavity, where the function goes from concave down to concave up. It changes its concavity. But for now, we need to know what increasing, decreasing, min, max. We got them all. Let me try another one. F of x equals 1/2 x minus sine of x. Again, I want to know where the function is increasing, where the function is decreasing, and what's the story with it? I need to know what the derivative is. The derivative 1/2 is what? And we want to test it, by the way, just this one from 0 to 2 pi, because it repeats itself, not including these values. So I want to know on this segment, just tell me right there where the function is increasing, where the function is decreasing. What's the derivative of that? 1/2 minus the derivative of sine of x, which is what? Cosine of x. Once you take the derivative, so take the derivative. Step number 2, set the derivative equal to 0 to find the critical values. So take your derivative, set it equal to 0. Here we go, 1/2 minus cosine of x equals to 0. That means cosine of x equals 1/2. Where's my unit circle? Between 0 and 2 pi. Where's the cosine equals 1/2? Cosine is the first number.
Pi over 3.
Pi over 3, and there's another one. 5 pi over 3. See them? Pi over 3, the cosine is 1/2. 5 pi over 3, the cosine is 1/2. There are two values. So now let's make our table. The book does a good job actually with the table. They label them. I don't label them, so maybe I should stick with the book way of labeling them. I like the way they do it. 1, 2, 3, 4. 4 layers. They make it. They want to write everything in it. I got it sitting here actually. There we go.
Remember? Dr. Z. When you played basketball. You could have made it.
Yep. The interval. So we're going to take this and cut it into pieces. And what we're going to cut it by, this is the 0 because we're going from 0, and that's the 2 pi. Because we're telling it from here to there. So I'm going to cut it into 2 more cuts. One of them is pi over 3. And the other one, 5 pi over 3. So the book labels them. So the first one, they label x between what? 0 and pi over 3. That's the first segment. The second one, x between what? Pi over 3 and 5 pi over 3. And the third one, x is between what? 5 pi over 3 and 2 pi. And we're going to pick a test point in each one. And where's my unit circle? That might make my life easy when I'm using numbers here. What should we use between 0 and pi over 3 so I can use my unit circle? Any value between 0 and pi over 3, what do you want to use? So you have 2 options, pi over 6 or pi over 4. Which one do you want? Doesn't really matter.
4.
Pi over 4? Okay. Between pi over 3 and 5 pi over 3. Between this and this. Maybe I'll use the pi. See that? That's an easy one. And between 5 pi over 3 and 2 pi, maybe I'll use what? 11 pi over 6? One of these 2 values. I'm picking these numbers. I know the answer to them. And let's find, all I care about is the sign of the derivative. Sign of f prime of x. Oh, look at how it's sign. You can tell I'm getting tired. I wrote sign first. I said, wait a minute, I need to write the word gn. Sign of f prime of x. Here's f prime of x. Where is it? If I use pi over 4, it's going to be 1/2 minus the cosine of pi over 4. What's the cosine of pi over 4? Square root of 2 over 2. Here's the good news. You don't have to do the math. This is 0.5. This is 0.7. That's a negative. All I care about is a positive or negative. That's a negative. This number is bigger than this. That's a negative. The value is not important. This one, pi, is going to be 1/2 minus, what is cosine pi? Cosine of pi is what? Minus 1. So 1/2 minus a minus, that's plus 1. Is that negative or positive? Positive. The last one probably negative here. What is cosine 11 pi over 6? Square root of 3 over 2. And that's a negative. Now the conclusion. The derivative is negative. What does that mean? Decreasing. The derivative is positive. What does that mean? Increasing. The derivative is negative. What does that mean? Decreasing. So guess what? Decreasing, increasing. What's the story with this point? That's a min. Decreasing, increasing. This one. Increasing, decreasing, that's what? Max. So I know where the function is decreasing, from here to there, from here to here. I know where the function is increasing, here to here. I know where the min, I know where the max. One more. And let's give you one that's really not increasing. If I can find one, it's not always going to be the pattern, perfect, perfect. You're going to have a problem here and there. I don't have anyone to do, but I'll go to this one for now. And still going to be pattern, like the same thing. F of x equals x squared minus 4 to the power of 2/3. So follow this step. I forgot to write the third step, which is what? Take a test point in each interval. Segment or interval. So I need the derivative. First thing first. 2/3. X squared minus 4 to what power? Negative 1/3 times the derivative what's on the inside, which is what? 2x. So that would be what? 4x over 3 times. This would be the cube root of x squared minus 4. You know how in this I set the derivative equal to 0 to find the critical value? We're going to do that, but I wasn't really accurate with that. I was accurate with this example. With this, that won't be accurate.
Do you need the cube root there? Is it square?
Cube root. Cube root. Yep. Thank you. So take the derivative. So to find the critical values, here we go, because you have a fraction now. There are 2 places. One is where the derivative is equal to 0. The other one where the derivative is undefined. So where's the derivative 0? Take the top of the fraction, set it equal to 0, which means x equals 0. Where the derivative is undefined, take the fraction, the bottom of the fraction, set it equal to 0. And we have 2 values. X equals what? Plus or minus 2. So now I get 4 or 3 critical values. My critical values are negative 2, 0, and 2. I'm going to make my table now. I need 4 layers of that. 1, 2, to write everything about it. 3, 4. Actually, maybe one more the way I do mine, because I write the value on the top. So this is really the negative infinity right here. I'm going to put the minus 2 right here. I'm going to put the 0 right here. The 2 right here, and that's infinity. So we took the line from negative infinity to infinity, cut into 1, 2, 3, 4 pieces. Let's write the segment, the intervals now. This is x is less than negative 2. This is x is greater than negative 2 and less than 0. This is x bigger than 0 or less than 2. And this is x is greater than 2. Test point. Or test value. Less than negative 2, what do you want to use? Okay. Between minus 2 and 0. Negative 1. Between 0 and 2. 1. More than 2. 10. Any number you want to. Next, the sign of f prime of x. The derivative. Let me just write the derivative because I forgot what the derivative is. There is a derivative. You're going to see me, I'm going to cheat here. When x is negative 5, so let's see the derivative at negative 5. I don't care what the value on the top. All I need to know is that a positive or negative. Negative, right? 4 times the negative 5 is negative number. Who cares how big the number? When x is negative 5, when you square that, what is that? Positive 25 minus the 4. Positive number, the cube root. Positive, that's a positive. What is a negative over positive? Negative. Not 1, negative here. It's negative there. So that means my function is what? Decreasing. Let's try the derivative at negative 1. Negative on the top. The bottom is going to be negative. What's negative over negative? Positive. Increasing. You can get a value if you want for it. And notice I plug it into the derivative, not the function. The function doesn't tell me if it's increasing or decreasing. What is the derivative at 1? At 1, plug it in. So that would be positive on the top, negative on the bottom. What's positive over negative? Negative, decreasing. And what about a 10? Positive on the top, positive on the bottom, positive. That's increasing. This is my min. This is my max. This is my min. Decreasing, increasing, decreasing, increasing. So basically the graph, have an idea what the graph looks like, but how is it increasing and decreasing, I really can't tell you. And I should find the y value for them. The minus 2 might be here, the plus 2 is here. The graph something like this, increasing, decreasing, increasing, decreasing. But it could be coming down like this and bubbling here. I don't know that part. Could be that. Actually, that's what the graph is. But we don't know from the first derivative how is it increasing and how is it decreasing. So then how is that? How do we figure how is it increasing or decreasing? Next section.